morning, grade 8s. Welcome to each and every one of you today, and I hope you enjoy the grade 8 natural sciences lesson presented by WorksheetCloud. If you have a question during the lesson, send an email with your question to grade8@worksheetcloud.com. So I really do think about you, grade 8s, and what you're busy up to during this time. And I am so proud that each and every one of you are still managing to find time to log into these lessons and continue with this learning. So thank you so much for being here today. However, it's really important that you also look after yourselves and your family and those that are around you at the moment. And it's also important for you to do a bit of self-reflection during this time. So I've got a few things that I'd like you to think about. And that is, what are you grateful for today? And maybe it might be important to keep a daily journal where you jot down each of these things and you can reflect upon it. Because I know at the moment things are really difficult, but it's a really cool activity to do. And then ensure that you check in and connect with your friends, with your family that aren't with you. So I want you to make at least one other connection or a check-in on someone today. Maybe you know someone who's all by themselves, or a friend that you haven't spoken to for a while, but connect with people. And then I hope you are making time to get outside today. I know it's a beautiful sunny day where I am. I'm not too sure what the weather is like where you are, but please take some time to get outside, get some sunshine, breathe in some fresh air, and just be grateful for the day that you have been given. Also, it's important that you do some exercise. I know that there are a lot of YouTube clips out there with a lot of fun things to do. So it's important that you do balance your lives out with a bit of exercise, and then take some time out to be creative. So to all you Minecraft people out there, see what beautiful creations you can make. And then back at home, in your house, what are you going to do that is helpful for the people around you? I am Mrs. Ernston, the WorksheetCloud Grade 8 Natural Sciences teacher. And remember to be ready for today's lesson, so have your books and pens and notes out so you can jot things down as we discuss them in class today. So this is a recap of the previous lesson, and I would like you to engage in this diagram. So the first thing I want you to do is just brainstorm this activity. So when you have a look at this picture, when you observe this picture, what is everything that you can remember from the work that we have done so far this term? So you might need to pause the video and spend about 2 minutes brainstorming everything that comes to mind about the particle model of matter when you look at this picture. So this is the note from yesterday. So I'm hoping that your picture looks something similar to this. So we discussed that water can exist in 3 different states: as a solid, as a gas, and as a liquid. We also made mention that water is actually a compound made up of the elements H2O. So here is a diagram of water made up of 1 oxygen atom and 2 hydrogen atoms. And then we also spoke about the fact that there are forces of attraction and repulsion between the particles of matter. So there are forces that attract these particles together, or that repel these particles, and that each state of matter behaves differently, and the particles in each stage behave differently. So because these particles are behaving differently, it allows us to have a compound that can exist as 3 different states. So on to today's lesson. What do you think about when you look at these 2 diagrams? So when I have a look at this one, I can just smell these delicious muffins cooking, and I can just imagine that smell wafting through the house. And then this stink bomb, that terrible, awful, sulfury stink bomb smell when someone has let that off in the classroom, and you just run out that classroom the minute that stink bomb has been dropped. So, how are these two images the same? How did you respond to these two images? And I wonder how these two images can be related to today's lesson. Well, let's find out. Most smells travel fast. So that is because their particles mix with air and get into our noses when we breathe. So we say that the particles diffuse through the air. So the air particles attract the particles from the muffin or the stink bomb, and they pull them apart so that they spread out through the air. The movement of particles of one substance between the particles of another substance is called diffusion. And the particles will move from an area of high concentration to an area of low concentration. So when you are in your room and you can smell the delicious muffins cooking in the kitchen, as you walk through to the kitchen, that smell becomes stronger and stronger until eventually it spreads out through the whole house. Let's have a look at this clip on what is Brownian motion.
You're in a darkened room, the air is still, and the bright lights are streaming through the window. What do you notice about the dust particles? The black circles as they pass through the beam of light. Pause the video and think about this. Press play once you've made up your mind. The answer is that the dust particles are moving randomly. Did you see it? The dust particles are not always moving downwards, but are moving in all directions. The dust particles are very small and are supported by a fluid. In this case, that fluid is a gas. You are unable to see the gas particles directly because they are too small, but you can see the larger dust particles. The reason that the dust particles move randomly are because of the gas. We know that the gas is there because every time we move our hand through the air, we feel them against our hand. Try it now. Continue when ready. The particles in the air move in random directions quickly. This means they will have many collisions or will bump into the dust particles many times. Each collision between air particles, very small coloured circles, show how the dust particle, the black circle, moves off in a new random direction. It's a bit like a game of snooker, where there are millions of marbles which collide with larger, observable particles like a ping-pong ball. This effect was first observed by scientist Robert Brown. He was looking at pollen grains suspended in water under the microscope, and he wondered why they jiggled around. He thought that the pollen was alive. It was later that scientists realised the importance of his discovery. Now, here's a challenge for you. Thinking about what we know about dust particles, can you explain why the pollen grains appear to be jiggling randomly? Pause the video and continue when ready. In summary, the fluid is no longer a gas, but is a liquid, water. The pollen grain is colliding with many water molecules. Each water molecule is too small to see, but we can see the combined effect of their collision to the pollen grain as it moves randomly. This effect is known as, you guessed it, Brownian motion.
So if we explore this topic a little bit further, let us compare the diffusion of particles in a gas and in a liquid. And tomorrow we're going to be looking at a scientific experiment that is going to cover the concepts that we do now. So, do particles diffuse or mix faster when they are in a liquid state or in a gaseous state? And which particles will mix more quickly, gases or liquids? You'll have to wait for tomorrow's practical investigation to find out. And then, do particles diffuse faster with or without mixing? So let's have a look at this little experiment now quickly. Is it possible to predict the direction in which the color would swirl? So think about it now. So we see a yellow liquid being added to a colorless one. Notice how the yellow liquid swirls and spreads out as the yellow particles mix with the colorless particles. Of course, we can't see the actual particles, but we can make a macroscopic observation of the process using the food coloring or dye and water. So what will the mixture look like when the colored particles are uniformly spread out amongst the water molecules? So can you guess what the next picture will look like? So what made the two liquids mix? How come? Let's explore a little bit further. What will the mixing process look like on a particle level? So there is a random movement of particles. So the particles in liquids and gases are constantly moving, and their movements are unpredictable. So in the previous slide, we couldn't work out in which direction the color was going to swirl. So we say that the particles moved about randomly. And it is this random movement of the particles that allow liquid and gaseous substances to diffuse. So what was actually happening? So this following zigzag diagram, when we go from A and we follow the zigzag line all the way to B, explains what is meant by random movement. So when a gas particle travels from point A to point B, it will collide with other gases along the way. So as it moves, it collides here, and it collides here, and it collides here. It can collide up to 8 billion collisions every second. So we've only shown a few collisions on this diagram here. But each time it collides, it's going to change direction. And it's going to change direction again, and it's going to collide and change direction again. So what that actually means is that the distance traveled by the particle is much further than the actual direct distance from A to B. So how do we explain this process that is responsible for the mixing and the spread of particles in a gas and a liquid? Well, we know that the process is called diffusion. So we know at first that the particles were close together, and we saw that after time they spread out and they filled the entire container. We can define diffusion as the random movement of a liquid or gas particle from a high concentration to a low concentration to spread out evenly. I know your teachers will want you to know this definition. So if you need to pause the video now to copy down what's on the screen, please do. So particles diffuse because they are in constant motion. So factors that affect the rate at which particles diffuse. So the speed at which particles diffuse depends on several factors, and the main ones are highlighted here. It depends on the mass of the particles. So obviously, the lighter the particle, the faster it will diffuse. It can also depend on the state of the particles. So the particles in a gas are always moving fast. So we say that they have an average speed is high, whereas the particles in a liquid will probably travel a little more slowly. The temperature of the particles is also going to have an effect. The temperature is a measure of the kinetic energy of the particles. So, the higher the temperature, the more energy the particles have and the faster they will diffuse. And then, the size of the spaces between the particles is going to have an effect. So, if there are large spaces between the particles of one substance, that means the particles of another substance can easily move into those spaces. So wow, it's really interesting. If you have a look at these factors here, we can create lots of different scientific investigations to determine the effect of these factors. And if you've got some time at home, why don't you go back and have a look at the activity using water and food coloring and see what happens if we change the temperature of the water, or if we used food coloring that had been iced up. And go and have some fun in the kitchen now, looking at solids and liquids, use some dye, see what's in the kitchen cupboard, and do some inquiry-based investigation of your own. And then in tomorrow's lesson, I can hear what you have found out. So I would just like to elaborate on this topic a little bit further. So explain why when a solid dissolves in a liquid, it seems to disappear. Where have those particles gone? So when we put some sugar in a glass of water, we notice that after a while the sugar has disappeared and that the water seems to taste sweet. So why don't you go and try this now in the kitchen and see why is that happening? See if you can explain why does this occur. So what have you learned today? What I would like you to do is write down 3 new things that you discovered and that you learned about, 2 facts that you found interesting, and you may possibly still have a question. If you do, please can you email that question to grade8@worksheetcloud.com and we will get back to you with the answer. So today we covered the particle model of matter and we had a look at Brownian motion and the diffusion and phases of matter. In tomorrow's lesson, we're going to be carrying out a scientific investigation. So if possible, it might help if you have these things prepared for tomorrow's lesson. You'd need a couple of transparent glasses. It doesn't have to be a glass. It could be a plastic container, but so long as you can see through it. A dropper is optional, but if you've got a dropper or syringe, that might help. And then any food coloring or dye or ink, or even if you've only got some juice, some flavored juice, that might help. We need a little bit of tap water, and then either if there's some vanilla essence in the kitchen, you might have room spray or deodorant, or you might have some essential oils around the house, or you might have a scented candle, anything like that. And if you are going to be using some type of vanilla essence or essential oil, then a shallow dish or a saucer would be helpful for tomorrow's activity. So if you can get all of those ready, and then we'll see you tomorrow. So thanks for watching grade 8s. This lesson was brought to you by WorksheetCloud.